Hi, welcome to the video demonstration of our project for the EEE3097S Electrical and Computer Engineering Design course. We are Group 2, and our group members are Kevin Merning, Johannes Folly, and Al Mouton. For this project, we are required to develop a wireless melody player. The system must consist of a mobile phone with a phone application with which a user can compose a tune to play. The information from this tune then needs to be sent to a transmitting Raspberry Pi. On the transmitting Raspberry Pi, the information must be encoded and transmitted to a receiving Raspberry Pi through either visible or infrared light. The receiving Raspberry Pi then needs to be able to decode the data and play the tune through a speaker. There are two design optimization criteria for this project, and they are that the speed of data transfer between the Raspberry Pis, as well as the distance between the two Raspberry Pis, be maximized.
The requirements of the system, so as to ensure full functionality, are as follows. System Requirement 1. The app component of the system must be able to store an array of musical notes specifying their duration and amplitude in the array. System Requirement 2. The array containing the information specified in System Requirement 1 must be able to be sent over Wi-Fi to the transmitting Raspberry Pi. System Requirement 3. There must be a Python script on the transmitting Raspberry Pi that writes the transmitted information into a text file for storage. System Requirement 4. The transmitting Raspberry Pi must encode the data found in the text file created in System Requirement 3 into a binary comms protocol and send this encoded information to the peripheral circuit on the transmitting side via the GPIO pins. System Requirement 5. The encoded information created by the transmitting Raspberry Pi must be transmitted using the infrared LEDs to the receiving peripheral circuit. System Requirement 6. The encoded information must be received by the receiving peripheral circuit and transferred to the receiving Raspberry Pi via the GPIO pins. System Requirement 7. The information must be decoded by the receiving Raspberry Pi. System Requirement 8. The decoded note information must be piped into a program that generates the audio that correlates to the given information on the receiving Raspberry Pi. System Requirement 9. The melody will need to be converted to an analog signal and sent into the amplification circuit. The amplification circuit will send the signal to the speaker, which will then play the melody. Here we see the entire project laid out. First, we see the transmitting Raspberry Pi terminal, and next to it we have the transmitting Raspberry Pi. On the other side, we have the receiving Raspberry Pi and its terminal. Here we can see the layout of the mobile application's user interface. Firstly, we can see the musical note buttons laid out one after the other from A to G. When these buttons are pressed, a preview tune generated by the mobile device can be heard. Next, the start, stop, listen and send buttons can be seen on the right. The start button begins the recording of the notes pressed and the stop button ends this recording. The notes pressed in this interval will be saved in an array, along with the amplitude and duration for which the notes were played. The listen button plays a preview of the array that is to be sent to the transmitting Raspberry Pi. The send button sends the stored array to the transmitting Raspberry Pi. On the far left, the volume gauge can be seen. This controls the amplitude value in the array that is sent to the transmitting Raspberry Pi. Lower down, we can see the song buttons, Song 1 and Song 2. These buttons play a preview of a pre-composed tune and send this tune to the transmitting Raspberry Pi. Right at the bottom of the application, a change mode button and a go up or go down octave button can be seen. The change mode button causes the sound played by the speaker amplifier configuration to sound like a guitar rather than the usual synthesizer sound. And the go up or down octave button causes the notes to be played an octave higher when pressed, and if it is pressed again, the notes will return to their original frequency.
There we go, that.
Here we can see what occurs when the send button is pressed. It can be seen that a toast appears on the mobile application containing the information within the stored array. It can also be seen that the same array appears in the terminal of the transmitting Raspberry Pi. The array was sent over a Wi-Fi connection via a socket connection between the mobile application and the transmitting Raspberry Pi. This satisfies system requirements 1, 2, and 3. Here, we can see the waveforms generated when the oscilloscope probes are put across the input to the transmitting infrared LED. The stop and start bits of the comms protocol can be clearly observed here. This satisfies system requirements 4 and 5. Here, we can see the waveform generated from the oscilloscope probes that are put across the input to the speaker. An FFT has been performed on this waveform and the output can be seen here. Due to the note A being the musical note which was played, the FFT here can be seen to be 441 Hz, which is very close to A's frequency of 440 Hz. This satisfies system requirement 8 and system requirement 6. Here, the process of recording an array and then sending this array can be seen. The values inputted in this array appear on the terminal of the transmitting Raspberry Pi. The transmitting Pi then sends it to the receiving Pi, which then displays the same array in its terminal. This satisfies system requirement 7. This next clip will demonstrate the entire working system, along with a demonstration of the change mode button.
No, intro this in.